Hey, good morning, everyone. So glad to not see you all, but glad to have you all with us today on our IDSA update session on the data exchange services. So this will be a really cool session in this Friday morning, so close to the weekend. So yeah, just relax and listen to our presentation. Of course, we will give you some time for comments and questions afterwards. Use the chat in the meanwhile, or ask your questions later on. So we have basically 4 speakers from IDSA. Today we have Silvia, Sonia, and we have Anil to present from IDSA side. And we have some guests today later on that will present their data exchange services, their connectors. So let me briefly, if it works, guide you through the agenda. First, warm welcome from my side for this IDSA update session. I will explain a little bit about data exchange services and how we see data exchange services on connectors in the Data Space Business Alliance as a very broad topic. And to keep the topic a little bit broad in the beginning, my dear colleague Silvia will briefly explain you about the OpenDI project and the building blocks that are available for data exchange. We will dig a little bit into the details of the data exchange services, how we as IDSA describe it in the reference architecture model, so the IDS connector. My dear colleague Anil will present you something about open source data connectors, so what is there for you to use and how you can get started with open source components. And then in the end, some IDS connectors on their way to certification together with our really welcome guest today. So let's get started. Data exchange service in the context of the Data Space Business Alliance, the DSBA. So basically, we started with an IDSA a couple of years ago with our connectors. The IDS connector, the IDSA connector, it's IDSA in general. Sorry, I have to move this one slightly. It's a common trust framework that specifies that everyone must use a specific data endpoint, our IDS connector. So this is for you as a participant, for someone who wants to share data or wants to use data in a data space. This is your service, this is your system that you will use to connect to a data space, to share data, to put usage policies on top of your data so that the user of the data can really understand, so what are the constraints, the obligations that I have to take, or what prerequisites do I have to bring to use your data. And therefore, to do so, the IDS connector provides a comprehensive set of data exchange services. So it's not only about sending data from A to B, there is a lot of more inside. And we will dig into this a little bit detail. And additionally, the IDS connector is a trustworthy environment. So it's a safe place for your data. Your data is protected inside. And so no one can manipulate or process the data against what you specified in your data usage contract. So this is basically where we started with the IDS connector a couple of years ago. And as data spaces became more and more important and more used by everyone, we started recently with the Data Space Business Alliance. So for all of you who don't know the Data Space Business Alliance, Data Space Business Alliance really as an alliance of some common initiatives, Big Data Value Association, the BDVA, Fireware Foundation, Gaia-X, and IDSA. We started to work in the Data Space Business Alliance to come up with one common voice and one common technical framework to make interoperable data spaces really happen. So altogether, we have more than 100 organizations from research and industry, some key players really to join our work and to work together on specifications, on standards, and to implement things, to implement especially open source systems and environments that you can use to build up your data spaces and to connect to data spaces. So of course, there's a cross-industry thing, so we're not focusing on one certain domain or one certain industry, we are cross-industry. And for me, personally, the most important thing is the technical coherence. It was a big question always, so how do those things really fit together? Who is doing what, who is providing what, and which initiative organization is working on which things? So we are boiling this down a little bit and try to come up with a common understanding how such a technical data space framework could work out for you. And this would be the best of breed from the DSBA. And I think all of you know there is a lot beyond DSBA happening, but what is within the DSBA, this is one common framework based on, as said, BDVA, Fireware, Gaia-X, and IDSA. So if we want to do something, where do we start? And this comes from the OpenDI paper, the OpenDI paper, Design Principles for Data Spaces, which was a really broad initiative to set up data spaces and to provide some guidance how data spaces could be built and how everyone could participate in data spaces. Silvia will dig a little bit deeper into the building blocks here and the OpenDI project itself. But we came up all together with a set of building blocks that you have to use, and they are organized in 4 pillars. The one thing is about data interoperability, and I think this is one of the most important things if you want to dig into data spaces. You want to talk about data models and data formats. So how can I share my data? How does my data have to look like? Which API do I have to use and to invoke? And how can I support something like provenance and traceability for data in a data space? So where did the data come from? Where did it go to? Who used it? And is there someone who has to pay me for using my data? So this is described here, and this is really about data exchange services. So what are the basic data exchange services to really exchange data? But it goes beyond that. A data space is always a place of trustworthy participants. And so the trust has to come from somewhere. So of course you have to be identified. We have to talk about identity management, who's a participant in the data space, and then how trustworthy is he or she as a participant in the data space, what kind of system is used, and which kind of usage policies could be enforced, for example, technically, and which could maybe only enforced on a legal basis or organizational basis, and how this can boil down really to assess and usage control policies. A very important pillar that is partly realized within the data exchange services, but here you always need a counterpart, so a trust framework, and I will come back to that later on. And then the third one, so if we want to share data, we want to create value out of this. So how can we create value out of data? Starting with, so finding the right data, finding the right services, so publish and discovery mechanisms, marketplace functionalities that go beyond just publishing data in, I don't know, a CCAN repository, in a federated catalog, in a metadata broker. So what comes beyond? So how can I do publication of really good data, put it on a marketplace, get data products sold and bought, creating contracts and so on. And then, of course, finally, data usage accounting. So these are the technical 9 building blocks in the 3 pillars. But of course, you always need something like a governance structure that really creates a data space, that sets up a data space. We talk of federators here on the one hand side, but also about data space instances. So how can you set up a data space? What is your ecosystem, your partnership, your domain where you're sharing data? And you need a governance structure for that to set this up and to make really use of that. So this was our starting point in this technical architecture coherence. And then we tried to map, so who is providing systems, capabilities, services for which box? How can we come up with a common framework? How do those things really work together? One important spoiler before, identity management in IDS is different than identity management in Gaia X, and the guys from Fireware again implemented something differently. So the question was always, how does this fit together? How shall this work? And we are solving that. So we have already a good approach for that, also a technical description, how to bring those things together and how to come up really with a common technical framework. I will not go into those details right now. So how do those tokens have to look like and so on, and which attributes do you need? That's not the point for today. But we somehow come up with a structure, how those things really fit together. So what is provided by the Data Space Business Alliance, by the partners in the Data Space Business Alliance, and what's up to you? How can you use this framework? So at the moment, it starts basically with the Gaia X trust framework, where we have registries for trust anchors. So who provides an identity, maybe an EIDA certificate, for example, or an ID union network, whatever, but we have to find those registries. So how does the trust really come from? We need compliance services that also come from Gaia X. So it is assured that if you step as a participant into such a data space, into such a data ecosystem, that you're really compliant with those things. And that also includes self-descriptions. Self-descriptions with the service characteristics here inside Gaia X. In IDS, you will have your self-descriptions for the data products that you can offer via your connector or offer via a metadata broker to be searched. So here the things really fit together. And we have a continuous compliance proof within Gaia-X, like the Gaia-X labels, which is an extensible framework to provide compliance assessments. So this is a basic foundation. We need a trust framework to set some things on. On top of that, for example, in the GXFS toolbox, but also in other Gaia-X services, we have continuous services that have to be used for authentication, authorization, notarization services to really onboard you into such a data space to verify. So yes, I am really Sebastian, I'm living here in Dortmund, and so on and so forth. And to have your proof in your pocket here, you need something like a wallet. So a wallet for a user, and also a wallet for your service, for your system that you want to use. So this is basically how the things connect to each other. And what we describe in IDS on top of that is for identity management, authentication, authorization, we have our DAP service, a dynamic attribute provisioning service, and we talked today about a support organization. So here you see something like a conflict maybe, but no, it's not a conflict. Things to really fit together. And just want to put a spotlight on this topic, which is super important. If we talk about identities, authentication, authorization, we have to distinguish between different things. So if we talk about organizations, if we talk about individuals, or if we talk about an application context, an IDS connector, or any other connector system as well. So these are just 3 different kinds of identities and authentication mechanism that we have to handle with. But basically, it boils down to a certain thing. And then we're currently discussing about this more centralized approach versus more decentralized approach. But well, honestly, that's not the important point. So both is possible. You can mix things, you can have a hybrid approach. It all depends on the system that you want to build, on the data space that you want to build. So how do you structure yourself? What is the role of a federator? Do you have some regulations that you have to put in place or not, and so on and so forth? So here you have some degrees of freedoms to put those things together. But from a service perspective, we don't talk about how the service, how the identity is provisioned. It's important that there is a service that provides a certain authentication and authorization mechanism that provides a certain identity. So this is where the things really connect to each other on that end. In the GXFS toolbox inside Gaia, we talk about a service catalog, so a place where I can publish my services. And to show and to give it available to you that you can use it, you can buy it or just instantiate it. But here is a big difference between the perspective that we have in Gaia and the thing that we have in IDSA. Cloud services might be not operational before I instantiate them. So first I have to buy it, and then services are instantiated. So basically that code that have to be brought to life. In IDS, we always talk about connectors that are active partners in the data space that can always publish their self-descriptions on their own. But that's not sufficient. If you have to know all the IP addresses of all those connectors, that's not very convenient. So here we are talking about a metadata broker where you can publish your self-description where someone can search and query and find your cool data products to use. So this is really the product perspective that we have here. And here the service catalog, the federated catalog, and the metadata broker, they distinguish partly. Basically, they do the same, and they could replace each other. But if you go to the specifics, there are some specific differences inside. For example, a metadata broker is still an IDS connector. That means you can really put usage conditions also on your metadata. So who is allowed to find my metadata inside a metadata broker or not, and under which conditions? While the service catalog is somehow more open to the whole ecosystem. I will not go into the details of that, even while it's interesting. And one box that was highlighted from the connector. So the connector has a lot of data exchange service inside, but there is data usage control, a real important aspect within IDSA. So how can I specify my usage conditions for data, and how can they be enforced later on a technical basis, on a legal or organizational basis? So this is one important aspect. And for the compliance in IDS, we talk about the IDS certification, which is somehow connected to the Gaia-X labels. So the one extends the other, or the one uses the other. So this is what we're currently discussing, how we can really make those fits together at the moment. An ongoing discussion. That's why you see the big work in progress on the slide. So this is not the final result. This is our current working discussion. So On that basis, you can instantiate or you can describe how you want to use your data spaces, but you also want to connect your data to it. And that means you have to talk about vocabularies. So how can I describe the payload of my data? What kind of data am I sharing? How is it described? What's part of it, what's not? So this is where we in IDSA describe vocabularies and how to use vocabularies, how to connect to others. Then you really want to ask, how do I do it practically? And this is where, at least not only here, but in a lot of places, Fireware comes in place. So Fireware is a lot of great open source product that can be directly be used based on the Fireware context broker with a lot of generic enablers. And here in specific, when I talk about vocabularies, the smart data models. If you don't know it yet, take a look on GitHub, the smart data models. It's a great collection of vocabularies that you can use for a lot of different domains. And Fireware provides a lot of other components, generic enablers that help you to instantiate, to build your data space or to build you as a participant in data space. And that includes, of course, also an IDS connector built on the basis of the Fireware ecosystem. So that's the basic idea that we have when we talk about data spaces inside the DSPA and which data exchange components and services we use. And if we put this in a slightly ugly picture, you can see how those things really connect to each other. I know that's not the most beautiful slide, but somehow it really describes, so what do we have to do? We not only talk about the data exchange protocols. Of course, you will have the endpoints, on the one hand side, the data provider, on the other side, the data consumer, and they want to eventually exchange data. But before you want to exchange data, you have to authenticate, you have to identify. And this is the first step that builds on something like the IDS Essential Services, on the GAIA-X Trust Framework, on federation services that have to be there to provide an authentication and an identification mechanisms. And of course, this has to be somehow validated, verified, evaluated via a certification mechanism, via labels, via a compliance proof. This is what have to be done before, and then you can use it via runtime, via authentication services. At the one hand side, on the other hand side, you want to connect to really value-adding services. That is, well, it's more fun to use data spaces with such services. You need things like contracting to make a contract between the partners, to pay for data, put usage conditions on top of that, a set of federated catalog or a metadata broker to search and query for something, to publish things, a clearinghouse. So if you need evidence, if you need a proof that something really happened or didn't happen, then the clearinghouse, data exchange logging services are the right functionalities. And you have to instantiate also some applications maybe inside, some code that will be executed to do something with the data to generate value out of the data. So, and these are the services that you have to describe. So if we don't focus too much on the components and how, for example, a federated catalog is built, but we need an interface, a communication interface, how you can use such a service. And these are the data exchange services that you need, that you have to implement as a comprehensive set to build to build and to use such data spaces. And on the other hand side, we need some internal functionalities that you maybe want to implement if you want to participate in the data space. Of course, things like user management and so on and so forth. So, but hey, let's go a little bit into the details of that beyond that ugly graphic. So what we discuss currently within the DSPA members, not all those data exchange services are mandatory. And here I have to underline in the DSPA, inside IDS and with the reference architecture model, those services are all mandatory, so you have to implement it somehow based on the IDS connector. And let me briefly list them. So it's authentication, as already mentioned, based on identities and trust framework. You can provide additional claims, basically how trustworthy are you. I have a level 1 IDS connector, a level 3 IDS connector. Additional informations like my data center is really located in Europe or it's not located in Europe, it's GDPR compliant and so on and so forth. So these are the basic mechanisms that we need and where we need some services for it. Of course, we need policy negotiation and contracting. The easiest way is I do not negotiate. These are my terms of use for my data product, for my service, and you can sign the contract or you don't have. But well, maybe sometimes you want to negotiate. So this is a service that you really need to understand contracts and to show, okay, at least I understood the contract and I will put it into place. But if we discuss here about policies, the focus is interoperability, because both of us, we have to understand what's inside the contract. That's the first step, to negotiate, to understand the contract, and to describe it. And what we discuss currently, ODRL is still a good candidate for this. We know ODRL has some certain limitations at the moment, and we can improve that while we're going with the services, but this is a good starting point. But that also means maybe you have to translate those policies afterwards. So we agreed on a data sharing contract. Both we signed this data sharing contract and we received the data, or we want to send the data. So that means maybe we have to translate or map those ODRL policies into something that is executable. Rego, XACML, whatever is reasonable for you, to provide access on the one hand side, and to provide mechanisms for usage policy enforcement, technical usage policy enforcement later on. So this is the basic things that we have to discuss and that we are currently clarifying and specifying. As already mentioned, we need something like a catalog, a metadata broker in the IDS world, somewhere where we can publish self-descriptions and where we can search for self-descriptions and find the product that we are really interested in. As mentioned, vocabularies, so to describe on top of the data product, so what is really inside, and that differs on a marketplace. It has different attributes. It's different if I describe a car or if I describe, I don't know, some food from a supermarket. We have a different language that we have to talk, and this is where vocabularies have to come in place. And what we discuss here, which is a super important topic, where we don't go into the detail today, is about controlled vocabularies, so that we really have a governance structure on top of that, that such a vocabulary is not easily changed, and then you have to fix your systems very, very fast after you realize, oh, something changed. Logging abilities to provide some evidence, apps, or in general an ability for code to data or data to code, and how to manipulate or process data in a trusted environment. And then finally, what we are basically talking about, it's data exchange. So send data from A to B or send the code from A to B to really create value out of the data. And this may have multiple instances. It's different if we have big data sets that might be sent on hard disk via FedEx. If we have some messages that have to be exchanged based on HTTP, if we have streaming data and so on and so forth. So this is really a big difference here that we have to understand. And then, of course, all the internal services that you might want to build. So some kind of user management, who can assess the data under which conditions. A trusted configuration management. If I have a trusted environment, then the configuration cannot be easily changed. Otherwise, we will have an attacking vector that we want to protect. We have to do some data and metadata management. Data typically lives somewhere or gets created somewhere. So how can we get the data and make it available in a data space, or get it out of the data space into our systems? And that also includes metadata management. Monitoring functionalities, is my service still healthy or not? Policy management, including policy enforcement, and things like data ad management and so on and so forth. So this is what your IDS connector always provides to you, what you can use, for example, based on open source components. So this is what we do in DSPA, how we specify and see things currently inside the DSPA, and it's under discussion. It's work in progress. So we are providing the first step of a comprehensive technical framework, but we are going there step by step. And where I also want to be very, very clear is, well, the DSPA is, of course, the best of all initiatives. But there are other components available as well, other things that you can use, that you might want to use, that you have to use because of the regulations or ideas inside your data space. And this is what the OpenDI project is there for, to provide a big overview on building blocks that are available for data spaces, and how you can not only exchange data, but also how you can really generate value out of data and use data. And therefore, I'm happy to hand over to Silvia for the current assessment on the OpenDI building blocks.
Good morning. Thank you, Sebastian, for this nice introduction and also for this great presentation. I am going to explain you, as Sebastian has commented, as part of OpenDI project, we are supporting projects and data spaces initiatives on how to implement, how to deploy data spaces. And as you already know, and Sebastian explained it, the design principle position paper provides a good overview. And in chapter 2, we define the building blocks that Sebastian presented. If you go to the next slide. the first slide. Yeah, here. Okay, so here we presented these building blocks, but then we realized that these building blocks are developed independently. So you can have different technologies, solutions that could fulfill this functionality of the building blocks. But for this reason, in OpenDI, in Task Force 1, we have started an activity to collecting the different implementations from different projects, data spaces, initiative or data spaces. Here you can find the barcode for answering the survey that we have started. With this survey, we pretend to map already reference implementations, technology solutions for each building block. So I encourage, if you have done, to enter and provide your feedback for one or several building blocks. And based on that, we will publish a building block catalog and a report. Next one, please. Can you go? Yes. Here you can see we have 33 participants on these activities. Most of them has contributed with building blocks. If you go to the next one, here and you can see in which building blocks we have got technical or implementation solutions, reference implementations, but we are missing some reference from interoperability, provenance, and traceability building blocks, data usage accounting, data value usage accounting, and the continuity model for governance. So if you have some reference implementation experience, please share with us. If you go to the next one. And what we will find, what we will achieve with that is that already we are not starting from scratch, because to provide these functionalities, we have IDSA, of course, and Gaia-X, as Sebastian explained it, and we are mapping also these technologies. But we have a lot of projects on the research program that are developing part of components of these building blocks. So with this building blocks catalog, we provide visibility and we are mapping of these components. If you go to the next one, I am finalizing. Yeah, this is the building blocks assessment report. We will provide per each building block, which is the status or almost the answer that we got, which are the technologies, the solutions, which has been the best practice and the reference implementations, and then what is missing and what is further needed to be achieved. So where is the gap? And I suppose that this information will be very useful for future projects, such as the Data Space Support Center. And also we are asking you some questions about data space prototypes in order to provide an overview of the data space harmonization, which are the characteristics of the data space that has been developed for the moment. If you go to the next one, the next slides, which is the roadmap for this project. Is we are producing a report and we publish the answer to the survey on GitHub. You have time at the end, up to the end of the month to answer, and then we will present the results during the next OpenDI final event. And if you go to the next slide, I invite you to participate, and you can register using this barcode. You can see the agenda of the event. Okay. If you want to get more information, you can contact me or go to the survey. Thank you.
Silvia, thank you so much. Indeed, a good point. So still something like 2 weeks to go. So let me share again. Still something like 2 weeks to go for your contribution to the building block assessment. So continue if you would like to. So that's really an interesting thing. I'm personally looking forward to the results of this assessment. So, but let's continue. Data exchange services in our reference architecture model 4.0. So what about reference architecture model 4.0 and the connector? What's the status? Oops. Well, a lot changed, but really not too much. It's still an IDS connector. It's still basically does work like it did before, but we changed some important aspects of the IDS connector, where I would like to dig inside because it's really relevant for our session today on data exchange services. What we didn't do until reference architecture model 3 was to address scalability. So somehow the IDS connector had something like this monolithic structure. It didn't really cloud ecosystems, for example. There you need scalability, but also into your enterprise systems, you need scalability. This was not really addressed so far. And this comes down also to another aspect of the separation of things like a control plane and a data plane. We didn't discuss this before in IDS, so this is a new concept that we also reuse now. So we didn't invent it, but we use it right now to really separate between a control plane that implements a lot of the data exchange services, authentication, for example, which is always required, but also connecting to other things and contract management. And then we have a data plane. So after you have created a contract and you really want to exchange data, we will send that to the data plane that will really implement the practical data exchange and the data processing then afterwards. And this really enables on the one hand side the reusability of some foundational aspects. So everything that is in the control plane can be easily reused. And on the other hand side, we achieve far more flexibility for the realization of data planes. There are so many different data planes thinkable depending on the data exchange protocol. As mentioned before, do I have a data stream? Do I talk about big data sets? Do I have only some messages that want to be exchanged? Am I just talking about some linked data and connecting things? And also with the internal structure to realize different capabilities like trustworthiness. I have a super secure data plane, including homomorphic encryption or whatever you like, or I could have a very lightweighted data plane that just consumes data and puts it in the database, and then we're good to go. And IDS needs really to support all those different use cases, really lightweighted ones, just putting things into a database, sending data from a traffic light into a data space, and super secure, high trustworthy data planes where the data cannot be easily manipulated, cannot be copied out of, and can only be used for a certain system. And this also opens options, for example, out-of-band transfer, if we really talk about enterprise or cloud solutions, to conduct the practical data exchange out of band, so not through the connector. That's also an option, and we open up for that with all benefits and all drawbacks that we have. So this is an important discussion. If we really do this distribution, the separation of those different planes, how can we keep those things connected and can cover all the drawbacks that we have and use the benefits. But let's get a little bit practical to our work. Oops. This picture, I think most of you know it already. This is basically the anatomy of an IDS connector, where we basically say, so it lives on something like a hardware, maybe a virtual machine. Typically, there is an operating system, and then we have some container management, some application management to really do some isolation, some separation between the different containers that may live inside such a connector. A custom container on the left that connects to your enterprise internal systems. The custom container, any type of a certified app container, so to put your application logic into this connector in a trusted environment. And then we always talk about this certified core container. And while in reference architecture model 3, basically we described there is one core container, we open this up with optional multiple containers so that you can scale up and just spin up some additional core containers, or you really separate the different services that we're talking about into different containers and therefore achieve broader scalability. So this is one important aspect to provide extensibility, more flexibility, and to distribution in a larger system. Of course, you can still boil it down and put all those things on an IoT device, on an IIoT device if required, but it's really more scalable right now from the structure that we have. But we are not here today in a systems perspective. We are here for data exchange services. And I love this weird diagram with a lot of wires and boxes, and then because it really explains how can a connector look like. And it's not meant that you have to build it exactly like this with all those packages and components, but this is a guiding structure. that you have when you talk about an IDS connector. The basic functionalities that you need. So it's still the idea that it acts between a bridge to a data space, which is basically the service on the right-hand side, and on the left-hand side, the internal structures working as a gateway, as a bridge, whatever, to connect your systems. It is still, from the internal view, a trustworthy runtime for data processing, and of course, it has to realize multiple different functionalities for data management and data processing internally. These are all the boxes that you have, from the practical data exchange to management functionalities into such a connector, including monitoring, for example, that you might want to use. So if we want to understand that a little bit better. So the core capabilities inside such a connector, I mentioned before, metadata management. So how can I describe the metadata of the data product that I can offer? How can I publish it to a catalog? How can I search a catalog and then make use of the results of my search and create then later on a contract and a data exchange interface? Practical data management, then how can I send data? How can I ingest data into such a connector from my systems, send it to a data space, and how can I really ingest data from the data space into my own systems? Implementing data usage control. So first of all, understanding policies, so making use of ODRL policies and understanding what do I have to do, what do I have to realize, the contract negotiation sequence, but also then really policy enforcement. So setting up technical structures that really realize those data usage policies technically. Of course, still provide a foundation for data apps to create their value out of data. So any kind of data processing apps inside that secure platform. So if you have to process the data inside such a trusted platform, then you can send apps inside, or you pre-process the data into the connectors and process it later on. But this all depends on the usage policies that you have negotiated. But that's the internal structure. From an external perspective, these are the right things that you can see. So connecting to the IDS components that we describe also. So identity management, authentication, the metadata broker, an app store, for example, a clearinghouse, participant information services, and of course a service to provide the self-descriptions. And here interoperability is really the key enabler that we are focusing on. On the slide before, this is more or less a structural approach, also how to assess cybersecurity aspects. Here we are talking about interoperability, and not only interoperability towards the IDS components that are described, but really describing the service interfaces. So how does a service look like? How are the services specified? How does my API look like, and how can I use it? But it has to go beyond that. We cannot only bind it to tangible APIs and protocols. We have to understand, of course, so what is the basic information model behind? This is what we have done with the IDS information model that describes, well, there is something like a participant in the data space, there is something like a connector in the data space. They have attributes and they have a relationship between each other. We have things like data assets that we want to share, and there are message types that can be used. And this is the second step that we have to describe here in this data exchange specification. So what kind of messages are described? Not as an HTTP message, but basically to describe the structural behavior with message types, but also with an interaction pattern. So what are state machines for such protocols, and how is it structured? How does the interaction between different components really look like? What do I have to do first? What second? And so on and so forth. And then we can really bind it towards a tangible protocol like HTTP, MQTT, whatever you would like to implement. So this is the structural approach that we have, and this is super important because interoperability is one of the key enablers for data space. If you can connect to a data space but cannot talk to anyone, then all the effort is in vain. So here we need a very clear specification of interoperability, and we have to validate interoperability later on. Briefly mentioned this. So this is basically our current work in process to update the IDS specification, our communication guide to describe information model that should base really on basic data types for data spaces as mentioned, the entities that we have there, and then reuse existing standards like DCAT, like ODRL as good as possible. We have to describe identities, the trust framework, how to get into a data space and mechanisms, and of course policies are an important aspect here. And then the connector capabilities like the data exchange from the control perspective, from the control perspective, the negotiation things, and then the data exchange things that we have to describe inside such a connector, but also catalog mechanisms, registration, so how to enter a data space, how to leave a data space, those processes have to be described. And then on top of that, continuing with capabilities like logging, the clearinghouse, app instantiation, and so on and so forth. So this is currently the idea that we have, what we are working on, and what we are providing beyond what was done inside reference architecture model 4. So this one is described. Now we have to dig into the details of the specifications, and our specifications can be always found on IDSG, where you can read the current status and see how we are currently processing with it. And if you enter there, you will find basically two different aspects. The one thing is the communication part on the left-hand side, so only to see how interoperability is assessed, how you can exchange things into a data space and make use of data space functionalities. And then we have the component view, so how IDS components should be implemented and how they could be assessed then later on, for example, with regards to cybersecurity and compliance to the IDS standard. So this is described how the systems can look like that you can make use of from an overarching perspective. And then we can go into really practical implementation, like our to-be certified products later on, or open source things. And that is what I would like to close with. So this is still our magic triangle with the 4 items: reference architecture model and specifications. They do provide a structure, an overview, a reference to implement your components, to understand how you can be part of a data space, how you can make use of data exchange services. We have the certification scheme that provides you a good overview on requirements from a cybersecurity perspective, but it also is a reference for interoperability. So you have to pass this one to really show I'm interoperable with a data space. I implemented those data exchange services in the right way. So feel free to connect to me, or I can connect to you because we are talking the same language. And this is implemented in building blocks. Open source building blocks, like Anil will present right now, are certified, maybe closed source projects that you can just buy from the shelf and use and implement in your data spaces. I would like to close with that one and then hand over to you, Anil, on the open source data connectors. The floor is yours.
Thank you very much, Sebastian, for the wonderful introduction, and good morning, everyone. So I will be focusing on open source data connectors today, and so as Sebastian mentioned right in the beginning, it all starts with a connector. So this is the reason why actually we have came up with this idea of the graduation scheme, the IDS graduation scheme, to be able to provide a curated kind of solutions for the data space enthusiasts to use, so that we have a list of projects that are IDS compliant, and their IDS compliance is approved by our technical steering committee. So our IDS graduation scheme is working pretty much like a methodology to assess the maturity level of the existing IDS solutions out there in the market. And currently we have 3 connectors as being part of it. So it consists of 3 levels actually. So the sandbox, incubation, and graduation based on their maturity level. So as we are in the very early steps of secure and sovereign data sharing, we have currently projects as being part of the sandbox level, and we are looking forward to have some more for the next levels. And also, you are warmly invited to apply to the sandbox, to the IDS sandbox project. So this is all open, and I will also share the link right after my presentations that would allow you to apply directly to it. So as mentioned, this graduation scheme is maintained by IDSA head office and mainly driven forward by our technical steering committee. So the barrier in the beginning for the IDS sandbox is very low, and so it's very easy to become a IDS sandbox project as long as your project is somehow IDS compliant. And then after your project gets adopted by more users and more organizations, then you can go into the other levels of the IDS graduation scheme. And so how to apply for it? It's very easy, and so you have, we will share the link to the IDS graduation scheme directly. You can just take a look on it. and then use the application form on IDSA website to become a sandbox project. And this is where you are just describing the basic details about your project and its relevancy to the IDS standards. And there are the projects that are IDS that are compliant with IDS standards. So one of them is Data Space Connector, which is based on IDS standards and following the IDS reference architecture model, and also applies the information model. And it's driven by Solidity, and it's also part of their offer of connector as a service. So you are welcome to check that in more detail. And then we have, of course, the Eclipse Data Space Connector, which is also applying the IDS standard for IDS connector, and so it's IDS compliant. And it's also adopted by the industry giants like Amadeus, BMW, and Mini, and Microsoft, and ZF Group, and Fraunhofer. And it's also ready to be used. And then we have Fireway True Connector, Trusted Engineering Connector, which is also, again, another open source implementation of IDS connector, and following the IDS specifications and standards. And it's under AGPL3 license, and it's open source like the previous ones. The Data Space Connector and Eclipse Data Space Connector are available as under Apache 2.0 license, and all in common these three projects have is they are open for contributors, contributions, and also collaborations. So these are great points to start. So you are warmly invited to check their repositories, their documentation, and choose the right one or right ones for you, for your case. And how to start implementing a connector. So first, we are strongly recommending you to check their documentation and their repositories and the level of implementation done. And then you are very warmly invited to become part of their implementation process, because after you check their contribution guidelines, you can see that we are always invited to contribute to the development process, as well as to provide feedback, and they are always open for feedback from their potential end users, and so please be part of it. And then, of course, as the next step, start with certification. So this is why I'm inviting my dear colleague Sonia Jimenez to the stage, and have a nice day. Thank you very much.
Okay, so I'm going to give you a brief update about the certification, but today it will not be me speaking about it, because today we have very special guests with us. So IDS certification was launched at the Hannover Fair in May. So we launched the first version of certification. That means we are now ready to certify the first connectors with assurance level 1 and 2. So either the entry level assurance level with the self-assessment, or the assurance level 2, so a more thorough certification where our evaluation facilities are involved, and they are the ones that are conducting all the tests for certification. After launching certification version 1, we launched an acceleration campaign, so to get the first connectors certified and ready to be offered to the market. The campaign was a success. We offered 20,000 euros for the second assurance level of certification, so the concept review. And we selected 6 candidates that are ready to certify their solutions. And these 6 candidates will be presenting their connector today. So yeah, so today we will give them time to present themselves and their solution. And we're going to start now with our friends from TNO. So I'd like to invite on stage Maarten Kollenstart from TNO.
Okay, I think I can't share my screen because of Mac security issues, but okay, I can share some words about the TNO connector. So that's can also do it without slides. So the TNO security gateway is basically a connector that we have been working on at TNO for about 3 or 4 years, and I think in the last weeks, we received the notion that we can apply for the certification. So that's what we'll be doing. And basically, the TNO connector exists of a combination of certain aspects of an IDS connector. The first thing that we will apply for is for the core containers, or the core part of our software suite. And this software suite is actually used within a multitude of domains. Most well known is the Smart Connected Supply Network, where we use our connector, where it's actually used inside the manufacturing domain inside the Netherlands to actually exchange order information between companies. But we're also doing more research-related topics with the connector. So actually have federated learning and more advanced topics with the connector. So that's what we are mostly working on, and that's all based around our security gateway. Also interesting to share is that we will make, especially the core part, also open source in October. So then it will also be available open source in an Apache 2.0 license, so everyone can use it and use it inside their offerings. So that's all from my side.
Okay, thank you so much, Maarten. Very looking forward to that open source version. So yeah, thanks a lot. And now I would like to welcome on stage our second candidate. Will be from colleagues from VTT. So I think Ilkka Niskanen will be presenting.
So hello, my name is Ilkka Niskanen. I'm a senior researcher at the VTT Technical Research Center of Finland. And the name of the connector that we are currently developing is called VTT DSLI connector. I will later explain in more detail what does this DSLI means. But the connector is based on the data space connector reference implementation. However, we will extend it with 2 additional features. So the first extension point is support for OPC unified architecture. So OPC UI is a machine-to-machine communication protocol for industrial automation. It's widely used across different industry fields for interconnecting systems or devices or machines. We are currently collaborating with many companies from the Finnish manufacturing sector, and for them it's really extremely relevant to have this support for OPC UI. So that's why we thought that this is an important extension point for us. So in practice, the connector will enable exchanging data retrieved from OPC UI servers. So this means that, for example, information about production machine state changes and so on. Another extension point for us is a more fine-grained access management. So we have received some feedback that we should be able to execute some user or role-based access management for different data resources and data products. So as a result of this development work, data providers are able to define individual persons or roles who can access the data. The deployment environment of our connectors, so as the data space connector, also our connector is implemented with Java, so it can be deployed as a Docker container, which means that it's quite flexible with the deployment environments. And the purpose of the connector is that it will be a significant part of our data spaces innovation lab. So the Data Spaces Innovation Lab, it's based on the IDSA reference testbed. So the aim is that it provides a experimental data space as a service for companies who are interested in data economy and data sharing. So in order to improve and extend this infrastructure, it would be really nice and important to have an, let's say, officially certified connector. I think this was from my side. Thank you.
Thanks a lot, Ilkka. It sounds really, really interesting, really promising. And I take the opportunity to say that the IDS reference testbed is available on GitHub. It's open source. We have described how to deploy it and how to test your connector there. So I really encourage you, as the colleagues from VTT did, to do that, to install the testbed and start using it, start testing your solutions there. So thanks a lot, Ilkka. And now I would like to welcome on stage our dear friends from T-Systems. So I think it will be Dandan one presenting.
Yes, can you hear me?
Yes, yeah, and we can see your slide.
Ah, you can see my slide. Great. I was wondering why I didn't see the screen sharing button. So now it's great. And so firstly, I'm the Dandan. I'm from T-Systems that's located in Germany. So that's a B2B subsidiary from Deutsche Telekom. And our core business is a telecommunication. And of course, data space is a data communication in the new world. So this is why we put a lot of effort and also the resource into this in the past 5 years. What we provided here in this process is Telekom DRH data connector. So this is, we have been through the past 5 years working very closely with IDSA, and we really appreciate this certification process. We also get very good information, very well guided. What we haven't concretely done is we're based on this Eclipse data connector, so EDC. So this is still the framework we developed on top of that. What we concretely is doing is, as Sebastian at the beginning mentioned, interoperability. That's a very much the problem we want to solve for the customers, because we want the customer just use as simple as it is a managed connector as a product provided from us and be able to connect it to the different data spaces. And we observe that the EDC, so Eclipse data connector, and the data space connector, they are not interoperable as it is out of the box. So what I mean is closing the contract, negotiating the different policies, and also do the data transfer as it is as simple as it is. So we tested, and then what we did is we do a bit modification extension as I showed in the slides there, so that we tested our result and deployed it as a Kubernetes application on the cloud, and that worked so that the data from provided from EDC can be closer loop and transfer to the data space connectors. So, and concretely, we have been using this this work in the different projects. The next slides, I list some of the projects. So, for example, mobility data space, they are mainly still using the data space connectors, and we are also part of it. And in the different other projects, for example, here, GaiaX for future mobility, we have several projects there. We're the service provider, and also in the Catena X, we are also providing the EDC-based connectors there. And this is where we want to provide the data providers the connector, which they can easily connect to all those data spaces. And this is our going forward effort to provide our product as a standard managed service from T-Systems. And meanwhile, we are also actively contributing to the open source community.
Great, great. Thank you so much, Dandan. It's really encouraging to see the work you're performing for data spaces. And you mentioned something very important, because we want to ensure interoperability between different connectors, and that applies to inter-data space interoperability, but also intra-data space interoperability. So we want to be able also to connect different data spaces. So
absolutely,
yeah, great progress that ends. Yeah, thank you so much, Dandan. Really,
thank
really
you
great
for
to
having
have
me.
Great. Okay, so now is the turn for our fourth candidate. That will be, we're going back to the Netherlands with our colleagues from Tech2B. So I invite Sjors Hooijen on stage.
Let's do a small introduction of we are a small startup from the Netherlands, building a smart manufacturing ecosystem. And we are adopting on the technologies that are Maarten from TNO and the Smart Connected Supply Network. And we're trying to to standardize order transactions for SMEs, and we do that for one-on-one transactions. And based on the technologies, you can now post also RFQs on our marketplace, on our supply and demand environment. So yeah, that's basically it. We are in the beginning phase, adoption phase. So eager to get users on board, and that's it.
Okay. Thank you so much. Yeah, very nice to see how this SCSN, how this initiative is also progressing, and now including the certified components into it. So really encouraging. Now we still have 2 more candidates to present. They weren't able to be with us this morning, but they have sent us a video to present their connector, their solution. So now we will share the video with you. We will start with our colleagues from WeTech in China, Anita, Dong, and Tony Cheung. So,
good morning, everyone. I'm Anita from WeTech. I'm honored to be here. Today, I would like to introduce you to WeTech and Shanghai of China. I hope that IDSA will be present in all cities and regions around the world. As you know, China has a very advanced manufacturing industry, and most of the companies are already integrated into the world supply chain. And the data is like a big river, flowing constantly between different companies in the chain. Broker of IDS is a lighthouse on this river of data, sending the right message to every boat. And the connector is like a port of entry on this river. Not every port you have the right to let it. WeTech wants to use the IDS concept and the technology to provide the right navigation for the boats in this non-digital river.
Good morning, everyone. This is Cheung from WeTech Hong Kong. Going forward, we will bring IDS to Southeast Asia, and Hong Kong is the starting point. Hong Kong is one of the most important ports in the world, and every day, a large amount of goods from all over the world enter mainland China through this port. And parallel to these goods is another digital world where the flow of data and information allows each link to complete its instructions in an orderly manner. WeTech is a professional cross-border data service company that handles huge volumes of data across borders for users in various countries in Southeast Asia on a daily basis. In the process, we apply the IDS concept and components to the important node of data cross-border trading so that the river of data flow endlessly. The cross-border flow and protection of data occurs between countries where international trade takes place, and we will allow supply chain data from all countries in Southeast Asia to share and flow in IDS ecosystems, allowing more companies in Asian countries to use IDS components. To this end, we will invest a lot of R&D work to ensure that more application scenarios are realized. Thank you.
And now we would like to present the video from our colleagues from engineering.
Hello, this is Angelo Marguglio, and I'm the head of the Digital Industry R&D Lab within Engineering Informatica. The True Connector, Trust Engineering Connector, is the IDS open source connector by Engineering. The component aims to enable secure and sovereign data exchange between two counterparts. It's totally compliant with the state-of-the-art IDS data space components like identity providers, clearinghouse, metadata brokers, and so on. The True Connector is available under the Engineering R&D GitHub repository, as well as the IDSA GitHub repository, together with the other open source solutions IDS compliant. The True Connector has also been integrated into Fabric Catalog, thanks to a dedicated fork with a customized app that integrates Fiber ecosystem in a plug-and-play way. This is disruptive. You can sovereign existing Fiber-based platform with no coding requirements, no barrier, just a matter of a configuration. The IDS connector by engineering is under IDS certification nowadays. In the following weeks, it will be certified, ensuring the satisfaction of all IDS criteria. The true connector has been validated in several contexts. During the IDSA launch coalition, implementing a use case in the aeronautics sector, in the Market 4.0 project, have a key component of the marketplace, being a pioneer of the IDS adoption in the high-tech metal and plastic domains. In the Eureka project, as one of the interoperable building blocks of the data space ecosystem, and in the Platon project, implementing use cases in the energy domain. Through connector, lower the barriers to be sovereign over your data.
Okay, that was the last video from our candidates. Thanks a lot also, Angelo, from engineering. It's great to see that your plans with the True Connector, so in how many initiatives, how many projects it can be implemented. And yes, we offer trust in the data spaces as one of our key pillars, and now it's finally happening. So now we're going to have very soon the first certified connectors, and you can see, you've seen where these connectors are going to be implemented, where they're going to be used, and we'll be bringing trust to all these initiatives and projects.